The Extremely Large Telescope, or ELT, is set to become the most powerful optical telescope ever built by humans. Located in the Atacama Desert in Chile, on top of the 3,050 meters mountain called Cerro Armazon, the ELT will give us a view of the universe that has never been possible before. It's not a space telescope, it stays on Earth, but with advanced technology it uses, it will even outperform some telescopes in space. The farther we look into space, the older the light we see. That means we are literally looking back in time. The ELT will allow us to see light that's been traveling more than 13.5 billion years, almost back to the birth of the universe. It's like building the time machine, not with wheels, but with mirrors, lasers and sensors. The ELT will help us answer some of the biggest questions in science. How did galaxies form? What are black holes doing at the center of galaxies? What is the dark energy, the invisible force pushing universe to expand? Most exciting of all, it will help us look the signs of life on other planets by detecting gases like oxygen or water vapor in their atmosphere. Let's put its power into perspective. 1 light year equals to 9.46 trillion kilometers. The ELT will be able to observe objects that are 13.5 billion light years away. That's more than 127 quintillion kilometers. That's 127 followed by 18 zeros. Imagine being able to see light that began its journey across space when the universe was only a few 100 million years old. And that's what the ELT can do. Now let's talk about how sharp its vision is. The ELT's primary mirror will be 39 meters wide, larger than a small football field. It will consist of 798 perfectly shaped hexagonal segments, all working together as one giant mirror. The mirror can zoom in up to 500,000 times. That's about 10,000 times stronger than your phone camera. In simple terms, if there were a candle on the surface of the moon, the ELT could see it from Earth. The resolution is beyond imagination. While your phone might shoot 12 megapixel photos, the ELT will capture gigapixel images, over a billion pixels per photo. That's like combining thousands of high-end DSLR shots into one single image. And it doesn't stop here. It can also separate light into fine pieces to identify what chemicals are present in the distant star or planet's atmosphere. Now, how is this technologically wonder being built? The ELT is a project led by European Southern Observatory (ESO) involving over 15 countries. The total cost of the project is expected to be over 1.4 billion euros or about 1.5 billion US dollars. This includes construction, instruments and operation for decades to come. The telescope's body and rotating dome are being built by a Spanish company called Ciner. The giant mirror segments are made by Schott, a German company known for advanced optics. Other major contributors include Siemens and MT Mechatronics for structural and electronic components. It's a global collaboration involving thousands of engineers, scientists, and technicians. The ELT uses something called adaptive optics. Earth's atmosphere makes a star look like they are twinkling, but that twinkle is actually distortion. To cancel it out, the ELT uses the laser guide stars projected into the sky. Then, secondary mirrors inside the telescope adjust their shape 1,000 times per second to counteract the distortion in real time. This allows the telescope to produce images as sharp as if it were in space. The dome housing the telescope is 85 meters tall and 74 meters wide. It can open, rotate and track the movement of stars with incredible precision. Inside the dome, the telescope's entire structure rests on a mount that can rotate and tilt, pointing to any part of the night sky with millimeter accuracy. Data-wise, this telescope is monster. One photo can be 20 to 50 gigabytes in size. A single night of observations could collect more than 100 terabytes of data. That's like downloading the entire Netflix library several times in one evening. In a year, the ELT will produce petabytes of data, requiring supercomputers and AI-based systems just to analyze it all. But this isn't the first time humans have built powerful telescopes. Let's quickly look back. The Hubble Space Telescope launched in 1990 with a 2.4-meter mirror and has taken some of the most iconic space photos ever. The James Webb Space Telescope launched in 2021 has a 6.5-meter mirror and can see in infrared, revealing galaxies over 13 billion light years away. On Earth, telescopes like Very Large Telescope (VLT) in Chile and Keck Observatory in Hawaii have mirrors around 8 to 10 meters wide. The ELT's 39-meter mirror will be larger than all of these combined. So what does this mean for us? It means we are entering a new age of space discovery. With the ELT, we may finally find signs of life on other planets. We may understand how stars and galaxies were born in the early universe. We may be able to measure the exact makeup of distant worlds and figure out if they have water, clouds, or even continents. And it's not just astronomy that will benefit. The technologies developed for the ELT, like advanced optics, ultra-sensitive sensors, high-speed data transfer, and AI image processing, will influence fields like medical imaging, satellite monitoring, weather prediction, and more. Constructions on the ELT began in 2014. Mirror installation is expected to begin in 2026, and the telescope will be ready to start operations called First Light by 2028. From that point, it will operate for decades, constantly upgrading as new instruments and technologies are added. The extremely large telescope ELT is not just a scientific tool, it's a symbol of what humanity can achieve when we push boundaries, collaborate globally, and pursue knowledge not just for profit but for understanding. It's a reminder that our curiosity is limitless and our ability to explore is only getting better. We often ask a question: are we alone in the universe? The ELT might finally help us find the answer.